modules installing, etc. So that's the only sure way we have. It's by digging in the make file to see what actually is listed as being prereqs. It's got slightly easier with the mymeta.yaml specification. Maker EUMM doesn't yet support it. Module install based distributions, unless the author has actually specifically said they want to do it. You can set some environment variables to make it do it, but we don't like to force people, so more often than not, we will not have a mymeta.yaml file generated when you run makefile.pl. You will with this build, will do it with when it runs build.pl, because modern module.builds do generate a mymeta.yaml, and we take that as kind of canonical if we find a mymeta.yaml file. If we don't find a mymeta.yaml file in here, the next course of action is actually to run a, if you know much about module build, you can have the build actions. So you run when you do .build space test, that's effectively an action. There is a action called prereqs. If you run that, it will generate a structure out of all the prereqs. Now, I have to do in here a sort of check to say, well, when did that become available? Well, it was in that version of module build. So that version of module build is that version of module build installed. Am I using that? Okay, yes, I will run this. But very often that can fail if the module author has actually installed or bundled an older version of module build that it gets used at the time. So the next course of action after that, if all else fails, is you have to dig around in the _build directory for a file called prereqs, which you can then evaluate and read in, and it produces a structure of the prereq. So prereq resolution is a little bit hairy, which is why these fellas take care of it for you, so provide that information. But you can create your own dist classes as well. Inherit from CPANPLUS dist base, and you can create distribution classes of your own. You can use CPAN2dist, or basically build dists in the format that you've specified. Right, we'll come to what dists are in a second. So custom dist classes, basically we use base, CPANPLUS dist base, and they can provide these, or override these different methods. Format available, that basically tells CPANPLUS, well, it's a little bit of code that will return true if this class is applicable. I have got an example of which one. That basically gets run by CPANPLUS to initialize the distribution class. And then these parts relate to prepare, is what will get called when you're going to run makefile.pl or build.pl. Create the make or build stage. And also the test stage is covered under that create method. And install, when actually going to install the files from lib, the lib part of the distribution folder after it's building it, it's actually going to put it into side lib or into lib. And we're going to install method, because CPANPLUS will install modules as well. Ooh, I forgot to mention a killer feature up front. Because I don't think CPAN minus does that, does it? I don't know. CPAN.pm definitely does it, but yes, we can uninstall.
So is that, if you, it doesn't rely on it having been installed by CPANPLUS?
No. I'm not entirely sure how it is. It's smoke and mirrors. I haven't looked too much at that code because I haven't had to fix it. So I'm not entirely sure if it uses the pack list, but then again, module build doesn't use pack lists. It just seems to work, which is quite cool. So, but yeah, that will get pulled if on your disk class if we're going to install anything. Here's an example. This is one of Yoss's ones because I thought the CPAN, because one I've written, which is CPANPLUS dist yak smoke, which is used by CPANPLUS yak smoke, is a little bit crafty and loads and loads of code, and a lot of it isn't relevant to the example, as it were. So this is CPANPLUS dist par, which creates par files, .par files from disks that you install. You inherit from this base. I highlighted that because that gets used later on here, but we're using module load conditional and importing the can load function. So in our format available method, what we're doing is we're saying if we can't load the par dist file, par dist module, then just return false and def or whatever to say we can't be used, this part can't be used, but otherwise we've got here we will return one and this format is available. During the create stage, there's a lot of fun things going on here. Basically, this module is of course the first thing on the argument list. The self, the second thing, or the parent of dist, is going to be self. See, this is where I got very confused when I was writing. I'm not entirely sure who's the parent of who here, right? You definitely can get at the back-end module from here. You can get hold of the configure module from the back-end module. And this CPAN here will be the installer that is used by, whether it be MM or build, that will be like the parent dist, because I'll come to that in a sec. Because what we're doing here is we're using the sort of we're calling the create method from the build or MM. If that fails, we would just want to bomb out. But at this point, you're saying, okay, we've actually successfully created and tested, and I'm going to create a par dist .par from the blib directory. He's just checking then for all sorts of error conditions, and then he moves the dist file to dist directory, which is under our .CPANPLUS directory. And then he just makes sure at the end that he returns a I've successfully created status back to CPANPLUS, or to the CPANPLUS module object, which this would be called from to sort of say, hey, everything's cool, I'm fit to go, I've done the job, etc. It's a slightly, I mean, there isn't any other bits today. It's literally just plugged in at the create stage. I make and make tests, or build and build test gets run. If that's successful, I'm creating a .par file, which will contain all this module, etc. And also, if he was using something like CPAN to dist, all the dependencies will be created as well, and have been created as .par files as well. This was the simplest one I could find. Some of the other ones, the the Debian ones, quite long and do all sorts of magic things that I don't understand. The .dev files, so I do fairly understand the par files. I'll move on to source engines. Because there's two engines that are available with CPANPLUS. There's the memory one and the SQLite. Was that SQLite? I won't say SQLite, but basically you get, it's presented with that module tree, an author tree. I didn't get onto author tree, sorry, but like module tree that we saw earlier, which is basically a hash of all the modules. There's one of author tree as well. So they, with the memory one, of course they're all in memory. We have load of author module, author objects and module objects. They're all in memory. It takes a lot of memory for all the 50,000 or so modules, etc. It does need quite a bit of memory. But CPAN.pm does a similar thing, which is why Miyagawa wrote CPAN-, so that he didn't have to eat all the memory on his slice host. And it's for this reason, the memory source engine eats a lot of memory, because it's stored in all there. SQLite is a little bit lighter, funny enough. Uses DPI, DVD, SQLite, to actually have a database with the indexes are in the SQLite database, and they are linked in by the same interface as the memory one by having a tie interface. Tie and a hash to basically database tables, so that when you query a module, you're effectively retrieving it from the database. It gets presented as it gets built as an object and gets presented to you. Because it's obviously not an object inside in the database, it's sort of table of data, and it gets sort of magicked into and created into an object. It does have a cache actually, so it will eat a little bit of memory. But it shouldn't be too bad unless you're installing the whole CPAN. If you're just doing, installing a couple of modules, then okay. Same, yeah. If you're installing something like Angerwhale, which has a dependency list as long as this table, you might eat a bit of memory, but that's how it does it. They're effectively, source engines have to present themselves as a sort of hash in the author and the module objects for those hash tables. Oh yes, this is fun. So this is the sort of processing it goes through to create the tables, update the indexes, etc. So we start off with the author tree, module tree, checks the trees. Are they up to date? If they're not, we need to update the source. So that will pull down the indexes and start re-indexing, etc. Which I think it will call this build trees. We also have custom module sources, which I'm going to come to in a sec. I hope I have time. Basically, it goes through all these things to build the trees, and it's quite scary following through the code. But it does seem to work, and it does provide sort of an independent way of sort of creating source engines. Because I did write one, which it's very memory light. I'm going to do a lightning talk about CPAN IDX tomorrow, so if you want to know a bit more about that. This is available now. It uses quite low memory, but it uses the CPAN IDX website to get the module data. So under the hood, it's sort of tied hash. But underneath, whenever you query a module, it actually goes off and does a fetch across the internet to the CPAN IDX database, brings it back and creates a module object for you and presents it to you. Similar way to the sort of, actually I ripped off the code from the SQLite engine, just sort of plugged in my bits and sort of, there are two scripts to do install and update in the examples for the distribution. Which I tend to, I use them as an installer one for installing modules.